Hello everyone. So in this video we will be talking about the terminating and non-terminating decimal expansions of rational numbers and how we can find out whether the rational number has a terminating or non-terminating decimal expansion without actually dividing it. And we know that a rational number is a number that can be expressed in the form p by q, where p and q are integers and q is not equal to 0. And on dividing p by q, every rational number can be expressed by either a terminating or a non-terminating, repeating or recurring decimal expansion. Now let's consider a few rational numbers. So first let's take 0.375. This can also be written as 375 by 10 raised to the power 3 or 375 by 1000. Second, let's take 0.104. This can also be written as 104 by 10 raised to the power 3 or 104 by 1000. Third, let's take 0.0875. This can also be written as 875 by 10 raised to the power 4 decimal places, or it can be written as 875 by 10,000. Let's take one more example. So we have 23.3408. This can also be written as 233,408 divided by 10 raised to the power 4 decimal places, so 4. It can be written as 233,408 divided by 10,000. Now if we look at this, we can say that here all the denominators are in the power of 10. So can we say that a terminating rational number has the powers of 10 in the denominator? But let's see now, they have some common factors too. So if we cancel 5, 200 and 5, 75. Again 25 3 times and 25 8 times. So this can be written as 3 by 2 raised to the power 3. And here we have a common factor 4. So 4 2 times 8, 6. Here we have 250. Then again we can cancel by 2. So 125 and 13. So this can be written as 13 by 125 is 5 cube. In this case we have 5175, 2 and this, then 25 7 times, and this would be 25 80 times. So this can be written as 7 by 16 and into 5. So 2 raised to the power 4 into 5. Now the last example, last 2 digits are divisible by 4. So we can take a factor 4, 2500, and here we have 4 5 times, 20 8 times, and 3 20. So 5 and 2. Again we have 4 common factor because last 2 digits 52 is divisible by 4. 1 and 18, 4, 23, 5, 35, 8 and 8, and here we have 6, 2 and 5. This is equal to 14588 divided by 5 raised to the power 4. So now we can see through all these examples that the denominator cannot always be 10. So we can say the denominator either has powers of 2 or powers of 5 or powers of 2 and 5. So in the first case we have powers of 2, in the second case we have powers of 5, in third case we have powers of 2 and 5, and in the fourth one again we have powers of only 5. If we have a terminating decimal expansion converted to p by q form where p and q are co-prime, then the prime factorization of the denominator q has only powers of 2 or powers of 5 or powers of both 2 and 5. That is, we can write down in the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers. So if the same thing we write down formally, we can write down as let x be a rational number whose decimal expansion terminates, then x can be expressed in the form p by q, where p and q are co-prime and the prime factorization of q is of the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers. So now let's think the other way around, the same thing. So suppose if we have a rational number in the form p by q and the prime factorization of q is in the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers. So let's take the same examples the other way around. So we had the first example 3 by 2 raised to the power 3. This I can multiply and divide by 5 raised to the power 3. So this I get the number as 125 into 3, 375 by 2 cube into 5 cube. This is 375 by 10 raised to the power 3 or 0.375. Second example, so it is a terminating decimal here. Now second one we got as 13 by 5 raised to the power 3. So this I can write down as 13 into 2 raised to the power 3 and 5 raised to the power 3 into 2 raised to the power 3. So both numerator and denominator multiplied by 2 raised to the power 3. This can be written as 2 cube is 8. So 8 into 13 is 104, and this is 10 raised to the power 3. So this can be written as 0.104. So again a terminating decimal point. Now third example again. So 7 by 2 raised to the power 4 into 5 we had. So this I can write down as 7 into 5 raised to the power 3 and 2 raised to the power 4 into 5 into 5 raised to the power 3. So this can be written as, this is 125 into 7. So that is 875, and we have 2 raised to the power 4 into 5 raised to the power 4. So total 10 raised to the power 4. So this would be 0.0875. Again a terminating decimal expansion. Now fourth one, 14588 divided by 5 raised to the power 4. So we have 14588 into 2 raised to the power 4 divided by 5 raised to the power 4 into 2 raised to the power 4. So 14588 multiplied by 16, we get 233,408 divided by 10 raised to the power 4. So this is equal to 23.3408. Again a terminating decimal. These are a few examples in which we have converted a rational number which is in the form of p by q, and q is of the form 2 raised to the power m and 5 raised to the power n, and we see that the decimal expansion is a terminating decimal expansion. So we can write down this formally as, let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers, then x has a decimal expansion which terminates. We learned that if it is a terminating decimal expansion, then it can be written in the form of p by q, where q has prime factors in the form 2 raised to the power m and 5 raised to the power n. And if we have a number in the form p by q and q has prime factors in the form 2 raised to the power m and 5 raised to the power n, then it will be a terminating decimal expansion. But now what happens if the denominator has other factors than 2 and 5? So now if the denominator of p by q has factors other than 2 and 5. So let's take one example. Let's consider 1 by 7. Clearly here the denominator is not in the form 2 raised to the power m and 5 raised to the power n. Therefore, it is not a terminating decimal expansion. Now let's divide 1 by 7. So we have 0 here, then decimal point, so 0, 1 times 7, again 30, then 4 times 28, and we have 27 2 times 14, 6, 0, then 8 times 56, then 40, then 5 times 35, 50, and 7 times, then 49, and we get 10. So this process will again repeat because it has again come to 10. So now it will keep on repeating like that. So all these decimal places will repeat or recur. So we can say here that if a rational number in the p by q form has q is not in the form 2 raised to the power m into 5 raised to the power n, or it has prime factors other than 2 and 5, then it is non-terminating but repeating decimal expansion. So let's write it down formally. So let's say let x is equal to p by q be a rational number such that the prime factorization of q is not in the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers, then x has a decimal expansion which is non-terminating, repeating, or we can say recurring. So from all this discussion, we have come to a conclusion. So this is a fun concept here. So now we know that if we divide the numerator by denominator anytime, it will be a terminating decimal expansion or non-terminating decimal expansion, or if it is non-terminating, it will be a repeating decimal expansion. For more concepts, stay tuned and see you all.